Well, hello everyone, and welcome back to Adrian's Digital Basement. On the heels of some Atari ST content recently on the second channel, I've decided to bring some Amiga content to the main channel with this Amiga 1200. This machine was recently donated to the channel by James, who also donated all those Ataris and a bunch of other machines. If you know anything about Amigas, you'll know that the 1200, like the Amiga 4000, suffers from capacitor plague a lot like Macintoshes, where the little surface mount caps leak all over the motherboard and cause pretty catastrophic damage. Not to mention you can have clock calendar cards installed in here as well that can also leak with the NiCad batteries, causing all sorts of damage. So in today's video, we'll touch on the history of the Amiga 1200 and what makes it a cool little wedge computer, and then we'll delve into what's going on with this computer, try to see what kind of damage has happened inside of this thing, and then ascertain what fixes this computer needs, and then try to assemble this into a full-fledged computer in this new case here and get this thing all up and running. So without further ado, let's get right to it. Now this particular Amiga 1200, as I mentioned, was given to me by James when James was downsizing and needing to clear out some space from his garage. And I don't know much about this machine. I don't know if it ever worked. I don't know if it's been recapped. I just don't really know what the deal is. It is completely disassembled, like nothing is screwed together. Everything is in pieces. And the case, this is the original as far as I can tell, it's in pretty rough shape. It looks like someone put screws that were too long around this edge. They popped through a little bit. There are a bunch of nicks and scratches all over it. And you can see that the keyboard is quite yellow, but oddly enough, the case isn't. So I don't really know what's up with that. But we do have one of these modern replica cases. I think this one is blue in color. There it is. Looks like you could also get it in a bright pink color or reddish pink if that's what you wanted. But we have a brand new blue case, comes with a new badge as well. Even though people who are regular viewers of the channel may have noticed, I have an Amiga 1200 badge that I've had for an unknown amount of time. I don't even know where I got this. I just had it taped up to the edge of my desk so I would not lose track of it. Well, if this label that's in here is not good quality and maybe this one's better quality, then I can use this one. When I looked through all the boxes of stuff that I got from James, one of the other things I found was this, which is an Amiga 1200 keyboard. And you can tell it is because it's got a ribbon cable connection in the middle here versus the Amiga 500 style keyboard that has a little PCB there that has a multi-pin connector. The membranes in these keyboards unfortunately can go bad where you end up with keys that don't work, and there are replacement membranes available, although I don't have any now. So if both of these keyboards are in bad shape, and actually this one is in bad shape, there's a hole through the membrane right there. That means hopefully this keyboard works, or I'll have to figure out something, like maybe I'll use an Amiga 500 keyboard in here. One thing about 1200s that I don't love is that the enter key on both these keyboards is sort of the European ISO style, which I don't really love. The layout on this keyboard appears to be UK because there's a pound symbol on the 3 key, while this other keyboard has a hash symbol on the 3 key, so like more of a US layout, but of course it still has the ISO enter key. Amiga 500 keyboards, as far as I'm aware, can work in these with a little bit of modification. One of the things about the 1200 as well is it can actually have an internal hard drive. If I lift the keyboard out, the hard drive sits around that location and it is not installed in the case. Well, while looking through all the stuff that James gave me, I found stuff that looked like it was for the 1200, so I stuck it all in this little box here. There are a couple Amiga ROM chips. We have what looks like a real-time clock calendar thing, takes a coin cell. Looks like we have all the screws, and it looks like the LEDs and stuff that go above the number pad there. And then there's the internal hard drive with its original mounting bracket. I'm pretty sure that's what that is. Looks like we have a cap kit, although these are all through holes, so not sure what that's all about. And then there appears to be what looks like an accelerator, and it says ACA 1221. And sure enough, I'm familiar enough with the Amiga 1200 to know that this edge connector, sort of like a PCI style connector, is the one that is underneath the keyboard. There's a little trap door there. And this has, well, it's hard to read what this is. Looks like a 68020, but I think it's faster. And the bigger difference from my understanding is that the 1200's RAM is only 16 bits wide to save cost, kind of like those Mac LCs. But this has 32-bit memory, fast memory right there, and the expansion header probably is for this real-time clock module. It seems to have a compatible header. That would give this computer a RAM upgrade plus 32-bit memory and a faster clock speed. So overall, I think you end up with a good performance increase. This has a 2015 date code on it. It says that the memory on the accelerator is automatically detected by Kickstart, but if it's an old version of Kickstart 3.0, only 1 mega is available. But with Kickstart 3.1, all memory is added automatically. Your accelerator comes with 9 megabytes of fast memory, and you can expand memory to 17 megabytes, 33 megabytes, or even 63 megabytes with a license code that's available from our shop. So I guess that means that this accelerator has the memory installed on it, and it's just not unlocked. If licensed, 1 meg of memory is reserved for a copy of a Kickstart ROM. Kickstart is the main ROM the Amiga uses. A lot of the system routines are in that ROM. It's on the motherboard. But to copy that into the fast memory of something like an accelerator will speed up the overall operation of the computer dramatically, because a lot of software uses routines in that ROM chip, and the speed of the ROMs on the motherboard is probably kind of slow compared to the speed of the fast memory on here, where it has direct connection to this accelerator processor. And that's why you would want to copy your Kickstart into the RAM and then run from that. This section here talks about the real-time clock that we have that we can plug into it. And then there's another section here that talks about a USB host controller. Looks like this accelerator is made by individual computers, good hardware for good computers. And we have a disk here, software for accelerators, ACA. The ROM chips I set aside for this machine are dated 1990, so I actually don't think they're necessarily for this. This might be for a different Amiga. I also don't know if this uses a single 16-bit ROM chip or two 16-bit ROM chips like this for 32-bit ROMs, which is something that both the Amiga 3000 and Amiga 4000 use. But the 1200 is a cost-reduced, inexpensive computer that's designed to be more capable than, say, the Amiga 500 with better graphics, faster processor, things like that. But Commodore still did cut a bunch of corners on this to bring the cost down, rightfully so. They just wanted to have an inexpensive but nice upgrade from the Amiga 500, which is what this is, the 1200. This capacitor kit, no wonder why it didn't look like it was for this machine. It says for Amiga 3000. That explains that. Now, from a history perspective, the Amiga 1200 codenamed Channel Z, or Channel Z, was first released in 1992 for a base price of $3.99 in the UK or $5.99 in the United States. And even when you look at the equivalent dollars in 2024 dollars, that's only $1,340. It was quite inexpensive. The Amiga 1000 was known to be relatively expensive when it first came out, extremely capable, but pretty expensive. Still cheaper than, say, the Macintosh, but more expensive than the Atari ST. And all of those custom processors or co-processors increased the price, obviously. But Commodore was able to get the price down dramatically with the Amiga 500, which came out a number of years after the 1000, and was price competitive with the Atari ST. Well, one thing about the Amiga, unlike Macintoshes and PCs of the era, was that the graphics chipset was so tightly integrated with the processor and everything about the way the computer operated. So you couldn't easily just upgrade the graphics system on it by, say, swapping a video card like you could with the later color Macintoshes and, of course, PCs. So the Amiga 1200 and the Amiga 4000, which was its bigger desktop brother, were really designed to be the upgrade to all of the previous Amigas, both from a processor perspective, but also from a graphics standpoint. With the biggest upgrade, especially for the Amiga 1200, being the fact that it came with a 32-bit 68 EC020 processor, EC being the low-cost variant of that chip. It also came with 2 megabytes of RAM standard, and that was chip memory, which means that it was suitable for use with graphics and sound. Chip memory on the Amiga is tied directly to the graphics chipset. Something like fast memory, like on that accelerator card, can't directly be used by the graphics system or sound. So you have to copy stuff between fast memory and the chip memory. All of this new chip memory was tied to the AGA chipset, and the AGA chipset stands for Advanced Graphics Architecture, as far as I'm aware. Let's see what it says here. Yes, Amiga Advanced Graphics Architecture. And this chipset was the successor to the older chipset, the OCS, original chipset, ECS, Enhanced chipset, and was really only used in the 1200, the 4000, and the CD32, the ill-fated game console that Commodore released, I think, a year after this came out. The main improvement you got with this AGA chipset over the older ones is instead of just 32 on-screen colors, or usually 16 depending on what game you were using, you could have 256 colors on screen all at once. And there was also a ham mode, hold and modify mode, which allowed for, well, it says here, up to 262,000 on-screen colors. There are lots of limitations with using ham, so it's not really suitable to games, but for still images, it works really well. And that allowed the older Amigas, even the original Amiga 1000, to display all 4,096 colors on screen at once, which you have to think about in 1985 was quite revolutionary. Another big improvement was that the chipset itself could talk to the chip memory, that's the 2 megabyte of RAM here on board, at a much faster rate. That allowed it to have better performance for even in the same graphics modes as the older Amigas. You had much faster graphics performance. Blitting, which is moving pixels around within the memory, was all possible to happen much more quickly. And this was especially important because if you're going to have 256 colors versus, say, 16 colors, well, we're talking about a lot more pixels that have to be pushed around, so therefore you really do need that extra bandwidth. Now, the thing about the 1200 is it's definitely a desirable computer in that, it's got those upgrades we talked about, but they didn't sell that many of them because Commodore went bankrupt by 1994. So it was really only on the market for 2 years. And here in North America, well, people were buying PCs anyways. There just weren't a whole ton of these. Now, when it comes to availability of AGA Amigas, that's the ones with the AGA chipset. There's really the 4000 and there's the 1200. It feels like in North America, the 4000 is the one that's more common. I think a lot of TV production studios use them with video toasters, video flyers, and just gen locking capabilities, hooking them up to the cable TV network for displaying graphics and weather channels and program guides and stuff like that. That was all a really common use case for Amigas here in North America due to the way the video hardware, even AGA, is native NTSC or PAL. So it's really easy to get broadcast quality video out of an Amiga with very minimal amount of extra hardware or really no hardware at all. Compare that to something like a PC, you're going to need a bespoke video card that outputs NTSC or PAL, and it's just not as well suited to working in that environment as an Amiga. But since the 4000 is a larger desktop thing and it could have cards in it, and you could have a fan inside and multiple hard drives and stuff like that, it just seemed to be more common than the 1200. I think by the time the 1200 came out, North American users were primarily moving towards PCs and to some extent Macintoshes. And that's what makes me feel that these just aren't that common here. And while I've worked on Amiga 4000s and actually own a couple of those, this will really be truly the first time I've ever actually worked on an Amiga 1200. All right, so taking a look back at the technical specs of this machine, one thing about it, and I don't think I realized this, is the Motorola 68EC020 that's in this thing. It's not what's in the photo there. It's a little surface mount chip. It only has a 24-bit address space, which is exactly the same as the original 68000 on the Amiga 1000, which gives us a maximum memory capacity of only 16 megabytes. We have the aforementioned 2 megs of chip RAM, and it says here that chip RAM cannot be expanded beyond 2 megabytes. Up to 8 megabytes of fast RAM can be added in the trap door. So that's where that accelerator goes, but you could actually just get normal fast RAM expansions that went in that trap door. But because of that 24-bit address space, 8 megabytes was the maximum capacity you could add for that type of memory. 8 megabytes is actually the exact same amount of memory that you could add on a regular 68,000 based Amiga as well, one that didn't have an accelerator, that is. I have to think the designers of the original Amiga looked at the 16 megabyte memory space and were like, that is so much memory, no one's ever going to need that much memory. And it's kind of nice they at least allocated half of it to go to fast memory. And then there's another chunk of it that can go to chip memory up to 2 megabytes, actually. I think that's the most that ever existed on the 68,000 based Amigas. And then the rest of it's used for expansion, cards, and I/O and mapping and the built-in peripherals and things like that. But that's actually quite a bit better than something like the Atari ST, which had a 4 megabyte limit for the 68,000 based Atari STs, and the same for the original Macintosh. When Apple designed it, they had the same 16 megabyte memory space, but they decided that 4 megabytes was the most RAM you could ever have, and that's why Macintosh SE, the Mac Classic, all the 68,000 based ones only have 4 megabytes of memory. Now, the funny thing is, I've actually bumped into this 8 megabyte limit before on an Amiga 2000, where I had a card installed in one of the slots that gave it 8 megabytes of memory, and then I was trying to use a bridge card that was a PC emulator type card you could plug in, and it wasn't working. And the computer didn't seem to really complain, but the problem was the bridge card needs some of that fast memory allocation for a buffer that it uses to transfer between the Amiga and the PC. And because there was an 8 megabyte memory card already in the computer, well, that was taking all of that memory allocation and that card couldn't have any. Other things about the 1200 that it has over the Amiga 500 is it has that IDE port internally, and it also has a PCMCIA Type 2 slot on the side where you can plug in some Wi-Fi cards, but of course a Wi-Fi card that's in that form factor is so old it doesn't support any modern encryption, so you wouldn't really want to use it any longer. And here are some specs on the machine. So our clock speed is 14.3 megahertz, about 2 times the speed of the original 68,000. Not to mention this is now a faster processor as well that has like internal cache memory, for instance. And the reason why the clock speed differs between PALs and NTSC is because the CPU on the Amiga and the chipset is directly tied to the frequencies that are used to generate the video signals. It's one of the reasons why this system is so great for video production. It's just so suited for video use. But on the other hand, it's the Achilles heel, and that you can't upgrade the video subsystem without, adding cards and incompatibility and all sorts of other issues. The AGA chipset did officially support a non-interlaced 640 by 480 VGA style resolution. You could actually use that on older Amigas as well, but the video performance was really poor due to a limited bandwidth of that chip memory and the chipset. That was improved, of course, with this AGA chipset. It's still slow, from my understanding, to use this mode, but if you're only going to run it, say, in like 16 colors or 4 colors, it's completely usable. Otherwise, you're going to be stuck using interlaced video mode, so 640 by 480, it calls it 400i here, or 512i for NTSC and PAL. There are a myriad of solutions for Amigas to line double the output to reduce that flicker. So if you were using a VGA monitor, 31 kilohertz, you wouldn't have to see the flickering lines. Problem is, the video internal to the computer is still interlaced. So if you move something across the screen in interlaced mode, you're going to have a combing effect because the de-interlacing hardware that we had back then didn't have the ability to try to, get rid of those artifacts like we have today. Again, this is one of the negatives about using an Amiga versus, say, even an Atari ST, which had a native 640 by 480 non-interlaced 31 kilohertz video mode from day one, and of course Macintoshes and stuff like that. So while the Amiga is suited for the video production work, it's less so suited for desktop publishing. I think that's one of the reasons why there weren't a whole lot of people using it for desktop publishing. And I can hear the comments now, oh, I used it for that and desktop publishing and stuff like that. But let's be honest, the Macintosh with like large, high-resolution monitors, because you could have video cards, really kind of took off in that market. And to an extent, even PCs with Microsoft Windows and other workstations, you can plug in video cards with high resolutions, high bit depth, and that's all just stuff that the early Amigas couldn't really do very well. I will add a caveat that there were video cards for the slot-based Amigas that could do high-resolution graphics. They were using VGA chipsets, basically, with a bunch of video memory, and software that was designed to use those types of graphics cards called retargetable graphics could be used. But something like the Amiga 1200 doesn't natively have any kind of card slots to take a video card. And while nowadays we have some modern solutions like the Pi Storm that can go on into this computer that can output that type of graphics, back in the day, that was just not possible. You were really limited to what you see here. Now, taking a look at the picture here of the motherboard, because I've never worked on one of these, it does have two 16-bit ROM chips. That does imply that I was incorrect in stating that it has a 16-bit data bus. I guess I was conflating that with the fact that it's got a 16 megabyte address space or a 24-bit address space, just like on the 68,000 machines. But the fact we have 32 bits of Kickstart ROM implies that this does have a full 32-bit bus. And that's probably the case because now I think about it, the AGA chipset in here is pretty much the same as what's in the Amiga 4000, and that's a full 32-bit bus, and it doesn't have the limitation of using the 24-bit address space either because it has a full 68030 processor or an 040 processor. Notice here these RAM chips, there are 4 of these as well, and that's got to be that 2 megabytes of chip memory. Pretty sure these are 16-bit each, so that's 32-bit plus 32 bits, so 1 megabyte, 2 megabyte. So that pretty much tells us that I was wrong about the 16-bit thing. Yeah, 100%. This thing does use 32-bit bus. That's cool. That's pretty cool. There are those surface mount caps I mentioned that are going to have leaked if they haven't already been changed, plus some there, a few more there. So we'll have to inspect here and look for damage. This particular Amiga has an extra connector there with a ribbon cable, and this probably had some type of a accelerator card that probably added additional graphics mode, that retargetable graphics I talked about. And this is probably something like a DVI port, or maybe it's a VGA port or something like that that would have plugged into the accelerator that's had been removed. I can see on this machine there's a hole where that thing is sitting. A little bracket would go there to hold something, and that knockout is missing on this computer. So I suppose when Commodore designed the case for the 1200, they thought, well, maybe we'll give them some expansion capability with the more capable trapdoor situation. That's this thing on the bottom here where the accelerator card can go, or just the RAM expansion card. And then that knockout in the case for video expansion or some other ports that you might be adding. One thing about the 1200 that people were upset about compared to the 500 and even the 1000 before it is those had a full PDS or processor direct expansion slot on the side of the case. That allowed the Amiga 500 to have external hard drives, external accelerators. There was so many peripherals for the 500 that plugged into the side, and the Amiga 1000 was no different. And with the 1200, obviously, they took that away. Over on the side where the expansion thing used to be is now just a card slot, and the other side has, well, this has a round hole here for some reason. I don't know what that's all about. Floppy drive, and on the back, yep, there's our little knockout. Well, with that out of the way, let's take a closer look at this 1200 and let's see what the condition's like on the inside. Well, and on the outside. taking my first closer look at this computer, all is not well with this case. I could see why James bought that extra case, because this is all cracked. This is actually broken. So something heavy must have hit this at some point. And this is what I was talking about when it comes to the damage of inserting screws that are too long into this part of the case where you have to use short screws. It actually pokes through the top of the case, and it did in those two locations. A little bit there as well. I'm still amazed at how not yellow this is. The original Commodore A1200 badge is in decent shape, luckily, and this is metal. Better than the sticker that came with that reproduction case. So I'll probably go ahead and pop this off, and there's a little hole in the back so you can pop that off without damaging it. Here's the keyboard that was in this machine. It's very yellow, but this is the one that I think is from Europe. And it looks like the ribbon cable at least is in good shape. Don't know how good the rest of the keyboard works. Funny thing is, you see how buckled this looks right here, and that's because the whole keyboard is bent a little bit. It's common when people stack stuff on top of these. The keyboard is really only supported on the sides and along the bottom edge. So when you stack stuff on it, it bends this part of the keyboard, and that caused that to buckle. But it's nothing that a little bending back of the keyboard wouldn't fix. See, it's already a bit better there. Here's what I was talking about with the other keyboard. It's filthy, obviously. It's missing a key and it has a broken stem, but it also has a hole right through the ribbon cable. So there's no chance this one will ever work, not without a new membrane, that is. The keys on this keyboard are much less yellowed than the other one. Even though they're just dirty, I think a little cleaning, it would go a long way to make this keyboard look pretty nice. There's a scratch here and some scuffs here and there, but I think maybe mixing and matching these two keyboards together, this one will look a lot nicer to use than that extremely yellowed one, especially on the new blue case that it's going into. Inside the computer, the RF shield is quite mangled. This is going to be the cable, I suppose. No, this is not the cable. This is a regular 40-pin IDE cable. I don't even know if I have a hard drive cable that will actually work in this. It's that high-density style cable that would be for laptops. Here's our floppy drive. This is a normal double-density floppy drive. It's made by Chinon, same as with the other Amigas. It's missing its button. Hopefully it's in that little bag of parts that we have. The RF shield just comes right off. And my first look at the motherboard. Well, right off the bat, we have two missing caps. That one's missing its pad, so I'll have to do some repair there. Luckily, we have very good resources available for us to fix these. It looks pretty crusty over here, so those are definitely original and haven't been changed. Same thing over here. This is all okay. The leakage doesn't seem too bad, though, luckily. What's missing over here? I think this is normal that chip is not there, for instance. And for instance, this header is not fully populated. All pretty normal stuff. Other than those caps, things are looking quite good. We have 3.0 Kickstart ROMs, so these are the original ROMs that would have come with this. The green bodge wire is definitely factory, but I do question if this is factory. Something happened over here. We have a missing pad, and things look pretty rough there. And this wire, I don't think Commodore ever would have used something like this. So I'm going to have to ask the community if anyone knows what exactly is going on with this little bodge. I took a look at that picture on Wikipedia, and that computer was also missing this IC. In fact, everything else looked pretty similar. Like this bodge was there on that. There was another bodge that went from a pin on this connector to, I think, that pin as well. But there was no resistor with the little bodge in that photo. Also, the one on Wikipedia didn't have any components there. And around the chip memory, things were pretty similar, except that the pin header that's there was actually fully populated. That one was not, and none of this stuff was either. This makes me think that they had thought about making it possible to expand the chip memory with some type of a clip-on add-on board, maybe to go to 4 megabytes, but perhaps later in the design process, the AGA chipset couldn't accommodate that, and they just left that off, but it was incorporated into the design. There's a little bit of damage and scrapes to this area. This would have been an RF modulator, which doesn't look like it was ever actually populated. There's just a hole there. Not sure if that's normal or what, but I don't see any rework in this area. I think the scrape came from the RF shield that was all crushed in that area. And this is all mangled as well. I think the computer itself got quite bent, which may mean that we have some issues with this computer that we'll need to fix. It could have broken some of the connections on these surface mount chips, but I won't really be able to figure that out until we get this recapped and powered up and tested. Besides the top shield being mangled and easy to remove, so someone had worked on this before, you can tell here that all those nuts are out from all the ports, so that tells us that someone has previously taken the whole motherboard out and worked on it, I suppose. There it is. And I'm curious to see what we have on the bottom. Oh yeah, the motherboard is bent. You can see that it's pretty bent. I assume that happened when the computer itself got the cracks in the case. Bottom of the motherboard looks good. Crusty flux on the IDE connector. I don't see any other obvious damage, which is good. So first order of business is going to be recapping this thing. And for me personally, when I recap a computer that's in my collection, just like this 1200 is going to stay in my collection, the way I do it is I use the twist method to remove these electrolytic caps. You can talk to 10 different people and you're going to get 10 different ways of the way it should be done. And of course, there'll be a lot of armchair people who say that it should be done a certain way. This is for my collection, this computer, and I'm going to recap it the way I recap stuff, which is always ripping them off. And I don't know, I probably recapped 50 motherboards at this point, and I haven't run into issues doing it the way I do it. In fact, for some reason, someone has already ruined one of the traces. But luckily, I know how to fix stuff as well. So even if I do rip a trace, it is technically possible because the corrosion just weakens the pads, and those pads are just glued onto the board. So they can come off. If they do come off, I'll fix it. This is not really a guide, just how I do the recapping. So I start with taking photos of the board just to make sure I have a record of the values of the caps and the orientation they're installed. Sometimes Commodore is known to have put things on backwards, and it's just good to have photo evidence. I use a good pair of needle nose, and I use what I should have called the wiggle method. So I push down on the cap and I wiggle it back and forth just to stress the legs that are soldered onto the board. I'm looking for metal fatigue to break the cap off the board. I'm not trying to rip the pads from the board. I'm just trying to break the little legs off. Occasionally when you take a cap off, a little leg is left behind, so you just wiggle it back and forth with your finger or needle nose pliers, and then it comes right off. All the caps came off easily without any fuss, and now I'm just taking a moment to inspect what's left behind. Definitely over by the power connector there was a bunch of leakage, but the rest of the caps actually didn't seem to be leaking too badly. And here are all the caps that I pulled off the board. Yay! Goodbye, guys. Goodbye. When you wiggle the caps off the board, it leaves behind the little legs that were originally soldered to the pad, so you do have to get those off. So I use a soldering iron that's set for 340 Celsius, add a little fresh solder, and then you just gently get those off the pads. What's funny is as I was cleaning the pads, one of them just came right off the board. There it is, just popped right off. But I just had the lightest touch on it with the soldering iron and it came right off the board. So I have a feeling it was already weak either from corrosion or something that had happened to it before. Then you have to clean off the old corroded solder. So use a little bit of solder wick. I'm just have an offcut here holding it with some tweezers because it gets really hot, and you just clean off all the pads. Corrosion on this board wasn't actually that bad, but I like to take a pair of tweezers and just sort of scrape around the pads just to make sure there's no crust that's left behind, because often it can get very crusty, especially if the corrosion is really bad. But on this 1200, it was actually kind of minimal. And like I said, the corrosion was mainly in this area, not anywhere else on the board. Since there are two pads that are missing, you have to recreate them. What I like to do is find the actual trace or the via that they were attached to, and I use my engraving tool just to clear off the solder resist to expose that copper. Then it's often a good idea to use the multimeter to check for continuity just to make sure that the pads that are in the corroded area or the vias and the traces that are next to the rip pads have good connectivity to the rest of the system so that when you put the caps back on, they'll make an actual connection. Then solder a little offcut onto that exposed part, either the via or the trace, and then I'll run that under where the pad used to be so that the new capacitor can attach to the offcut. This type of work can be pretty fiddly, but doing it is not impossible. And I know some people like to use little replacement pads, which you can buy, and little copper strips that can replicate the old pad, and you have to glue them down. That obviously will visually and cosmetically look a little nicer than the way I'm going to do it here with these little offcuts. But to be honest, the offcut method does work perfectly. Okay, this is how the board looks in that corroded area with everything all cleaned up and those two offcuts installed. There was a little bit of flux on the offcuts just to make it easier to solder the cap onto them, and that's what that brown stuff is there. So I went into my little stash of capacitors and I found all the appropriate capacitors for the machine. I did have to look up a chart to see what the ones that were missing from the motherboard were. I'm using all electrolytic caps, a little round aluminum type, and then I'm using two ceramic MLCC types. It's just what I have on hand. And I know some people say that these aren't suitable for this type of work, but I've used these so many times on so many different computers and I've never had any kind of issues. Plus, they will never leak in the future. Then I like to apply a little bit of flux onto the pads of the capacitors that I'm about to apply to the board. I like to install the caps one value at a time, so I put it on the two ceramic 47 microfarad ones first, and then I like to install all the other values in groups. It just helps me avoid any mix-ups with installing the wrong value cap in the wrong position. Another thing I like about the ceramic caps is they're non-polarized, just makes installation that much easier. The way I solder all these caps on the board is I hold them down on top of the flux onto the pads, the cleaned pads, and I solder one side first. And I just try to get a little bit of the solder off the tip of my iron onto the side of the capacitor. Then once the cap is attached on one side, I can go back with the soldering iron and apply fresh solder to the other side using some actual solder. And then I'll retouch up the original joint as well, just to make sure that you have a nice fillet of solder. I think that's what that's called, that nice shiny joint you get when you have a good connection. It was at this point I noticed I forgot to remove one of the caps over by the video connector, so I went ahead and ripped that off the board, cleaned the legs off, and then cleaned up the pads, and then I attached the appropriate capacitor to that spot. Now it's just rinse and repeat for the rest of the caps. Apply flux, place the cap on the board, check the polarities the correct way, solder one side, solder the other side, touch up both joints, check your work, rinse and repeat. For the two capacitors right by the top edge of the board between the RCA jacks and the keyboard connector, I used a very fine point on my pine steel soldering iron. That made it possible to get to those joints without melting anything or having to remove any of those components. Well, since all the caps are on, I'm just inspecting my work, just making sure that they all have the good fillets on them and they're looking connected properly. Of course, the two capacitors that are over in the section with the damage are a little wonky because they're sitting on top of a little metal offcut, but they have a good firm connection to that metal offcut, so there are no issues there. The final step I like to do is just clean up some of the flux, and I use a little bit of 99% IPA and a small brush, and I try to be gentle, especially on the area where the corrosion was, and I did those repairs because I don't want to rip anything off the board again. A brush and a small paper towel goes a long way in getting all that extra flux off the board. And the final thing I'll do is I'll just blow some air across it just to get any of that residual IPA out from under the large ICs. There we have it. The board is recapped. I didn't see any other damage while looking around because I was looking pretty closely at the board. Definitely could tell someone had been working in this area. We had the one cap with the ripped off pad and then another one came off while I was recapping it. I could tell someone was sort of tinkering down here. Maybe they were starting to do a recap and aborted once the pad came off, not knowing what to do. But I think we're good to go with this board. I cleaned it up a little bit as well, just had a bit of grime and dust and stuff on it. And now it is time for testing. I'm going to use this modern power supply that I have for testing, but before I do that, I want to make sure that my capture setup is good. So I'm going to bust out the field found Amiga 500. Yes, this is the field found Amiga 500. I can always tell because I just have to look at the bottom of this machine to see all the rust that's coming out of its orifices. And the back is all rusty as well along the ports and stuff like that. If you haven't seen the video on the Field Found 500, I will link it down below. It's another testament to reliable, cheap, inexpensive computers. I'll be capturing this using my Extron 300A, so it's plugged into this VGA converter. The Extron is not the best scan converter for the Amiga or the Atari ST, but it does work. It can be a little fiddly. It's good enough for what we're going to be doing here for testing. So let's turn on the Amiga. I mean, it's possible that this Amiga is broken. There we go, workbench 1.3. Okay, capture setup looks good. The Amiga 1200 uses the same power supply and video connection as the 500, so any kind of cables you got for one should work fine on the other. First, we'll start with just the video and the power connected. Let's see what happens. 3, 2, 1. Uh-oh. Yeah, it's not a good sign. So the power supply is lit, but we have no video at all. That makes me feel like there's no voltage getting to this, because just the fact that it'd be powering up the chipset, even if CPU weren't working, you'd expect to see something. But I'm not familiar enough actually with the AGA chipset, or really actually the ECS chipset on the older Amigas either for that matter. If there's no CPU activity or the ROMs aren't working, do you get any video at all? Or you just have absolutely nothing? Because that's what we're getting here, is absolutely nothing. Now, one thing I noticed is over in this area where the cap was ripped off, this component is also missing. And it kind of looks like maybe something was there at some point. So let's see what we have voltage-wise when I turn on the Amiga on both sides of this component. All right, we don't have anything on it, so that might be normal. There's 5 volts on this other component. Let's check over here by the floppy connector, power connector that is. So we have 5 volts there, and on this side, 12.5. Okay, so we have good voltage making it to the actual system. This ROM chip has 4.9 volts as well, so that tells us that definitely voltage is getting to things. My assumption is the system is not executing code, and when that happens, you don't get any video whatsoever. Well, that means that what I thought was just a simple recap and clean up and put the computer back together is actually a repair video now. All right, the oscilloscope is fired up. Remember what we need for a working computer? We need clock, power, and reset. Well, not in that order, obviously. So first thing I'm going to do, and not really follow my own advice, we're going to take a look at some of the pins on the ROM chips. They're the easiest to probe since it's not surface mount. All right, so I'm probing one of the legs, and it's weirdly noisy. The system is off right now. Let's see I don't think I'm even getting a good ground. You know, I've been having problems with these probes. This is a Rigol probe where the ground lead fails. Yeah, I think this ground lead is bad. These all came with my 1054Z scope. Pretty sure all the ground leads have failed, and it's something like inside the wire here that's gone bad. And I bought some more, and I don't remember if I ever got them. I think I ordered some, and the order got canceled, and yeah, okay, well, that's annoying. Whenever you see that noise like that, that's a good sign that there's a problem with the grounding, especially when the system was off. And touching the ground should have changed something, but it didn't. So let's switch to one of my cheapy probes, one of the ones I got for some of my really crappy oscilloscopes. Notice there's no noise or whatever, and if I unplug the ground lead, then we have a bunch of noise. So if I touch this, yeah. So that confirms 100% that that lead from the Rigol scope was definitely bad. Okay, so let's turn it on, touching one of these pins. Well, that seems like normal activity. And the fact is, when I turned the power on, it took a split second before the system started running. Yeah, so I think the reset circuit is good. Okay, well, that's good. The processor itself is this small little component down here. That's the processor on here. Is anything hot? No, things are just very slightly warm. So that's good. All right, let's check the composite video output. I don't know, maybe there's a problem with the art. Wait a second. That's a video signal on the composite. So why on the RGB were we not seeing anything? Or not? I just switched the input and, well, there it is. What? I didn't touch anything. I didn't even unplug the video cable. It's exactly the same. And if we turn the power off and back on, oh, now it's not working. What's going on? Well, there's the Extron. The video signal's getting in. Oh, hold on a second. What if this is a problem with this jack? Could this jack be damaged or have bad solder joints on the bottom? I mean, we checked the voltages before, 5 volts, and it was fine. Now it's not working? Let's see if we have the waveforms on the chips. Yes. Looks like normal activity, just like before. And then when I switch back, there it is. My hunch is that the video signal was there all along. And unfortunately with the Extron, there's no way for me to see, there's like no status information to see what video signal is on there. I've looked through all the menus, believe me, there's nothing there. So perhaps when I power cycle it, there is a video signal there, we just can't tell. And what's happening is the Amiga is trying to access the floppy drive right now, which of course isn't even connected. So all is actually running normally. And the fact that it was a black screen was just, I don't know, a red herring. And if we just wait a little while, there we go, yes. So that's a big difference with Kickstart 3.0 and later. Kickstart is the main ROM that we're looking at here, this purple screen. All the earlier versions, when you first turn on an Amiga, you kind of get a white or a gray and then a white screen. And then you'll get something like that to say, you know, insert the floppy. Either the old Kickstart 1.3, like on the Amiga 500 we just saw, or this more modern animated version, which I think came out with 2.01. But 3.0, I think, just sticks to a completely black screen while it's looking for the floppy disk. And when it can't find a disk, it times out and then you get that screen. Well, that's a great sign. That's telling us that this Amiga appears to be working. So that's pretty funny. I'm glad I didn't go through any deeper troubleshooting. I think next thing I need to do is get this floppy drive connected up, and there was no cable, I noticed. There was the power cable, luckily, and that's good because that's a little different, but the ribbon cable was not inside the computer when I took the computer apart. The disk drive goes something like this, so it just needs to go from there to here. So I just need to find a little ribbon cable, 34 pin, same as a regular PC floppy cable. So here's a normal PC floppy cable, and yeah, it's got all extensions and stuff on it. From this connector to this connector, it's a straight through. So we'll see if that's what the Amiga needs. And for testing, I'm going to use a copy of Amiga Test Kit, which is an awesome diagnostic utility that's on a floppy disk. So first we'll turn this on and see if the floppy disk is even seeking. This does not have an LED on it. The LED, oh, it actually connects to this little header. Remember I asked earlier about what this header was? That is for the LEDs, power LED, floppy LED, and maybe hard drive LED. Cool, so I'll just grab that, connect it up. That way I can see if the floppy drive is being accessed or whatever. Back in the day when I worked on computers a lot, the pin 1, which is the stripe on the cable, faced the power connector. That was the standard way of doing it. But on this Chinon drive, yeah, there's no actual marking to tell you which way it is. So hopefully it's right. If it's wrong, usually what happens is the light just comes on and stays on solid. The floppy light, that is. Which is which one of these? I don't know. We'll figure it out. Here we go. 3, 2, 1. All right, so it's probably this middle light, that's the floppy light, and it is just on solid. So if we unplug the floppy drive and we try turning it on again, yeah, that light's not on now. So that means I had this cable backwards. So wouldn't you know it that on this Chinon drive, the stripe, pin 1, is towards the side of the drive and not towards the power connector. The motherboard is marked. There's a pin 1 right there, and the stripe on the cable is towards pin 1. Okay, let's try this again. 3, 2, 1. There we go. The light's not on. Let's put this disk in. Oh, I might need to clean this drive first. I hear the drive clicking and making noises, so assume it's actually being addressed by the computer properly. So there we go. The light turned on when I put the cleaning disk in. It's trying to access it, which of course it can't. All right, let's put it in the floppy disk. Oops, knocking things over. Oh, it booted. Awesome. That is so freaking awesome. 68020 AGA NTSC 60 Hertz it says there. I'll put a link to Amiga Test Kit down in the description. I highly recommend it just because it's so useful for testing keyboards and disk drives and Amigas in general. All right, so any kind of shimmering that you see, don't worry about that. That's just the capture device doing that. So we can do a RAM test. So we have 2 megs of RAM. That's excellent. That's what we should have. This is not a very good RAM test, but it's certainly a RAM test. What you're looking for is it to say round 2 or 3 or more than 1. That's when it loops around. The Amiga itself does a quick RAM test when it first powers up, and it will flash a color on the screen if there's a problem. And there we go, it totally passed. So that worked. If we had the keyboard hooked up, we could test that out, which is great. It just shows a picture of the keyboard, but we don't have it hooked up, so we can't test right now. Floppy drive, I suppose we could test this. I need to make sure this disk is right protected. It is. We'll do a read test. You can ignore this late spin up thing. It always says that. I think that's maybe when you're running this program on NTSC. Cool, all tracks are okay, so the drive is working. This doesn't really have much for video test. It just shows this, and it will show this on a regular Amiga as well. Looks good though, so that's good. You can test serial parallel ports, some CIA stuff. I'm not sure any of this does anything really useful. Okay, yeah, well, it says test pass, so that's cool. We don't have a battery backed up clock, and we can't really check the peripheral ports. I think that's like some of the extra I/O lines and stuff like that. There's much we can do. It does show you your chipset IDs though, so there we go, F8 and 33, whatever that means. Last thing we're going to do is the audio test, and I have the audio leads hooked up. We'll hit audio, and there we go. Plays a mod file, and it sounds perfect. And there's a filter. We can turn this off and on. That works. And you can turn the channels off and on if you want. Spice it up by Jester/Sanity. Well, this is awesome. This thing totally appears to be working and complete as far as I'm aware. I just have to make myself a floppy disk cable. So let me go crimp on a new 34-pin connector and make a little short cable for this disk drive. Well, I didn't have to make a cable. I went into my box of cables and I found this floppy cable, and this I think this should be perfect. Don't think this came out of an Amiga, but it is perfect length. Now, I would be remiss if I didn't spend at least a moment to open this floppy drive up and look inside just to see what it looks like and how dirty it is, because if the grease is all bad, then I should at least try to clean that up. To open this top cover, there are little clips on the side. I just use this little poker thing to push those off, and wow, that's actually not that bad. It's not nearly as dirty as I thought. And you know probably why is there's no fan on this sucking dirt into the drive. There's certainly dust in there. See, running the Q-tip inside, it's picking stuff up. But it is not that bad. I'll just blow a little air through here. Just careful not to blow too much air on the head area. See down to the heads, and they look pretty clean, so I'm not too worried about those. And the mechanism itself is working nicely. Doesn't feel all gummed up or anything. Sometimes if there's grease that's all caked up on the little screw thing there, you can put some new stuff on there, but it doesn't really look like there's any on there at all. Let's just do a quick check. Oh, I guess there was. Okay, I'll put some new stuff on there. Just a little bit. So I have a little bit of lithium grease on here, and all you gotta do is just put some on there, and as the head moves back and forth, it will drag that grease around. So that's probably too much, but it'll be fine. I'll actually wipe a little bit of that up there. There we go. Now inside this bag, what's in here anyways? What are all these bits? Is the button for the floppy drive in here? I don't see it actually. That's kind of annoying. I'm sure it's something I can 3D print, but it would clip onto this and stick through the side of the case. Let me grab the case so we can look at what that looks like. There it is right there. So the button would stick through that. These things here, these are not the buttons, right? No, that can't be. All these little broken pieces though. I wonder where these all came from. Okay, now looking at the case, I can kind of make out how this works. So the floppy drive sits there and must screw in, yep, into that metal bracket. And then this little piece that I put on sits right there, and you would screw in from the bottom of the case. So that's how the floppy drive mounts. And the button should stick through the case, the bottom case and the top case. Now, when it comes to the lower RF shield, I think everyone watching knows I don't love RF shields, but the bottom one you do need on Amigas. You don't need it, but it's good to have because you attach the shield to these connectors and it just adds a little bit of extra rigidity to the connectors. Although this shield is very bent, but I have a feeling once I install the nuts again, I have to go find some that will work, then it will pull this kind of straight. Also, you know what? I just realized what's missing. There would have had to have been some kind of a plastic sheet under here so that there's no chance of the motherboard actually making contact with the board. So I'm going to cut out at least a piece of paper to sit under here. I just don't want things like these connectors and stuff to potentially touch this if the computer flexes. Oh, you know what? I have this. I don't know where this came from, but this is better than nothing. It's a good start. It's not going to cover this area, but I'll cut out the rest of this, and then I'll just have to augment this with paper. There we go. I just used the rest of that plastic sheet, and I think this should be completely perfect for this application. In fact, I'm pretty sure this came from some other computer, was underneath a motherboard or whatnot, and I saved it because it's always useful to have stuff like that for cases exactly like this. And now I just need to find all the nuts that go in these connectors, and I have a whole bunch here, and it's going to be this type. It's not going to be the brass standoffs. Those are from motherboards and stuff like that. What's going to be good about getting these nuts in is it's going to give the motherboard some strength and rigidity as well, since this whole metal structure will just help reinforce it and it won't bend so much. Some trial and error later, all the nuts are installed in all the ports and the motherboard is a lot less floppy, and I feel a lot better about it now, especially connecting things like the video cable. That's always a thick cable. Now the motherboard, once it's screwed into the case, should be nice and sturdy. Speaking of case, let's take a look at the replacement casing. Yes, Amiga 1200 dark blue, it says. Dear backer, Christmas 2016, the Amiga 1200 rises. After a year of development, you are now holding the new Amiga 1200 case in your hands. Having requested a longer period of time to mature, the case is now yours in quality it deserves. Here is a nice and shiny, ready to host your beloved Amiga hardware for the 20 years to come. This is Amiga licensed and it came from a1200.net. Not sure I would have picked the blue color personally, but you know what? Beggars can't be choosers. To be honest, this is way nicer than the case that the computer came in. So really, I am not complaining. Plus it's distinctive. It's very, very distinctive. All right, so it looks like we have an Amiga 1200 badge. We have, oh, a blue floppy drive button. button. Okay, that's awesome. Got some standoffs for motherboard, I suppose. Don't know about that. Oh, this is for that port that's missing. The extra port, I guess if you want to install a VGA connector or something like that. I suppose this is for that. Yeah, I don't love that. Where's that 1200 logo sticker that I have? Here it is, right here. This is the one that's been sitting on my desk forever. This is definitely a replica. The Commodore logo is metal and raised on the original badge, which I'm gonna take off the other case, definitely. You know, one thing I realized that it doesn't have, maybe they fell out, feet. Oh, they're already on here. Nice. Oh, I like the sticker. And a trapdoor with a vent on it. That's fancy. Okay, so this already has the screws installed. So let's pop those out. Ooh, and I can see fancy pants. This has metal inserts for the screws. Nice. Okay, the cover is released. Interesting is on the screen, I can see it just look kind of a blue color, but it's kind of a dark purple almost in real life. Inside the bottom cover, got signatures. That's awesome. Manufactured by A1200 under Amiga Inc. license. Okay, let's stick in the beloved Amiga into the case. So one thing I noticed is that besides the top cover screws, which it does come with these there, it doesn't come with any screws to affix the motherboard down to the case. And that's kind of annoying, actually. Let's see if we have any of the screws in this bag that I thought was all Amiga 1200 parts, maybe. Although this is a real hodgepodge of parts here. I'm pretty sure a lot of this stuff is not for this computer, the 1200 that is. I found 5 of these small screws, which I would say these look correct. These have a Torx head to them. And it looks like there might be 5 screws that hold the motherboard down. 4 screws, actually. Actually, it seems like there's only 2 screws I can use to hold this down because this one over here has a large opening on the back. So it's almost like you screw in from the bottom side into something on the top side here. Actually, and the floppy drive, that needs to go in that position there. So I need to take that out. And if this screw doesn't fit through, I need to use a longer one. Okay, I've been trying to figure out how to get this button on, and unfortunately, it looks like this drive and this button are not compatible. That's kind of sucky. Maybe in Europe, another drive was more common than this chin-on one. I'm gonna look around to see if I at least have a beige button for this. Hopefully I do, because not being able to eject the disk without sticking a screwdriver in there will be annoying. And I have a bag full of like floppy parts, and it looks like this is another one of the same button. Has a screw stuck in it, but this is the same exact button that we have here. So obviously this is common enough. It's just not that drive. I found another bag full of floppy parts, and maybe, just maybe, what I need is in here. All right, so many buttons, and none of these are what that drive needs. And in this bag, same thing. Not a single button for this drive. Wow. I found one that kind of fits on here. It's definitely not the right one. Doesn't latch on, but it does go on there. It's just, yeah, that's not going to work very well. Let's see what happens if I place the cover over the floppy drive. It's in the right position, so that's better than nothing. That's definitely better than nothing. That'll have to be something I have to fix at some point in the future, at least. Well, I've been spending a bunch of time trying to find screws just to go into the disk drive because it has to go through the thick case and into the bracket for the disk drive. And the pitch of the screw is something I have, but not long ones. And I really, really wish this case would have come with screws. I can only imagine this was very expensive to buy back in the day, and it just feels really cheap on their part to not have just included the screws. Maybe it was an optional extra, I don't know, but really, how much could that have raised the price of this thing? Okay, the question is, what should I test next? We do need to test the keyboard, and one thing I'm concerned about is I think this is a 0 insertion force connector, and it's like the top part's missing. You should slide this up, get the cable in there. Maybe it doesn't have one. No, I think it did, and it's missing. That means that the keyboard is not going to work here. Let's just test this out. Yeah, that's a showstopper. This just fits in there, but it just doesn't go in anymore because the clamp or cinch part is missing. That's disappointing. That's very, very disappointing. At least the keyboard fits in the case properly. That's good. I'm kind of curious about the hard drive that, oh, look, it has the cable. Okay, so the hard drive just goes through these slots on the motherboard. Doesn't look like it actually screws down. The Seagate hard drive is obviously the original. Now this is just IDE, which is good. It means that you could easily replace this with a compact flash card, for instance, or a more modern hard drive. And I happen to have some modern IDE style drives. I mean, modern as in newer than this. Keyboard probably rests against this part right here. Yeah, the keyboard is like supported by the hard drive itself. Yeah, that ribbon cable doesn't do anything. It just sits in there. So that's not going to work at all. I suppose I could try to wedge something in there maybe. So the contacts are on this side that face the back of the computer. So maybe if I cut out a piece of card, I can just wedge it in the back. In fact, I have some of this plastic card that I used for the under tray. This is probably a good thing to try with. So I'm going to put the ribbon cable into the connector, and then I'm going to wedge this card in behind it. Okay, well, it's in there, but unfortunately, it's not thick enough. This is not thick enough. I'm going to need another one of these. Here's another small piece. I'll just tape this together onto it. All right, there it is, double thickness. See if that works a bit better. So I'm going to flip the keyboard over. And that gives me access to the side that I need to wedge this in from. Okay. Cable's actually in there, everyone. Flip this around. All right, it's kind of interesting. So the keyboard sits on the floppy drive, and I noticed there was a little copper thing there, and I guess that's to make contact with this. And then it also sits on the hard drive there. Is the hard drive in place? Yes, it is. Right. Maybe we're good here. I guess I'll turn this on and we'll see what happens. The hard drive should spin if it works. Hard drive is actually spinning. F2 keyboard. Hey, look at that. 5 doesn't work. It could easily be a bad membrane though. That is very, very common. Backspace doesn't work. Okay, T doesn't work either. So this could be a problem with the connection as well. Enter works. Yeah, the fact that we have a whole row of keys so far kind of screams, uh-oh, the whole bottom row doesn't work. Spacebar doesn't work. Alt doesn't work. So I pushed every key, and what you see there is what doesn't work. So I'm just going to fiddle with this connector in the motherboard a little bit. F4. Oh, yes, yes. Bottom row. Okay, X is not working. Okay, so far we're just with 9 and X, but this could easily be the keyboard. So all I have to do is just jiggle with this a little bit. Okay, there we go. So I think it is a connection somehow, because if I lift this out slightly, it starts working. How about this 9 over here? Yeah, that's working now too. So maybe for this little wedge thing, I need to cut one more little piece of plastic for this to make it a little bit thicker. And I'm just going to put a little bit of magic eraser on the contact pads. They are fragile, so just a tiny bit. There we go. All right, I wedged it back in there, and that's with an extra third layer on there. And would you look at that? Just like that, all the keys are working. Unfreaking believable. That hack worked. So I'm curious if we eject this disk and control Amiga. Oh, there we go, it rebooted. Oh, the hard drive spun down. I wanted to see if I could actually boot off this hard drive. It cannot. Okay, interesting. So I mounted the LEDs on top cover. I used the 2 screws I found in this pile of missed screws. Okay, I'm putting this back together. I have the 3 screws on the back end, plus 2 for the floppy drive, and the 3 on the front edge, but I noticed that there's space for 2 more screws, and there are little standoffs there as well. So now I have to try to find some screws that are gonna work in there again. All right, all the screws are in. This thing's feeling nice and solid now. So that means this thing, well, it's all together, other than the lack of proper eject button. Let's just test that one more time. If I pop this in, it's not the end of the world. That's as far as it sticks through, but you can push it. So, okay, that's okay. That'll work for now. I got to transfer the badge over from the other machine. This keyboard, I think after being cleaned, probably will look a lot better than this very yellowed one. There, I just gave it a little bit of a wipe down on the tops of the keys, and you can see that that looks a lot more pleasing than this one does. It actually wouldn't be too difficult to switch this entire top piece over. what you do is you take all these little screws out the back plate comes off along with this bad membrane anyways. Do that on this one, swap them around. I'd have to fix this, so probably take a stem off this, put it on there, and then we'd have one yellowed key. But I think that's something I'll do after I'm done with this video, but that'll look a lot better than this thing will. All right, what I want to do now is I want to see if this computer still works now that I've assembled it. Are these LEDs in the correct orientation? Power, floppy, hard disk. Yes, they are. Cool. Now, hopefully it comes across on camera, but these LEDs are sunk in a little bit. Therefore, the little standoffs that they installed at the bottom of the cover aren't the right height for those LEDs. So that's kind of annoying. Cool, but the computer still boots up. That is freaking awesome. So I've hooked up a GoTech drive to the Amiga, and that's what I booted up into. And what's funny is, well, it's not doing it now, but whenever the internal floppy drive does a tick, which is typical for the Amiga, the screen was dimming. So I'm wondering if I'm having a capacitor issue of some kind. Could be those electrolytics, potentially. Oh, see, there, did it right there. Click, yep. Very interesting. I've never had an Amiga that had this particular fault before, so I'm thinking there's something with the capacitors. I don't think it's my power supply because it says it can do 4 amps, 5 volts, and 12 volts is 0.5, but don't know if that matters. Also, no hard drives are showing up. HD setup will now partition and format your hard drive. Which hard drive should be partitioned? It says Amiga 1200 HD is usually unit 0. So, unit 0? Sorry, an error has occurred. Could not partition the hard drive. Well, we're kind of on uncharted territory since I don't know much about Amiga 1200s whatsoever. Well, so I just ran show config 68020 AA NTSC Alice. That's the AGA chipset. There's our Kickstart version, exec version, disk version. There's our 2 megs of chip RAM, so it's from 400 hex to 1 FFFFF. I don't know what it's supposed to do when it comes to the IDE interface on this. Does that show up in here or not? The flashing is really annoying. I'm gonna have to do a little bit of reading to see what exactly is causing this flashing, and it's either the power supply I'm using or it's some of the caps on the main board. And because the floppy drive is causing it, I feel like it's the 12-volt rail, and maybe 12 volts is used in the op amps for the video output circuitry. Now I do have another power supply, and I'm pretty sure this one has a mean well inside, so I've changed out the guts. And this one, in fact, I'm noticing here it says field found 500, and yes, the power supply was completely toast inside there, and it's definitely a mean well. So let's try this one out. I've just never used that small black power supply that I'm using on a 1200 because I've never had a 1200. I mean, the computer itself was working fine, so I think the 5-volt rail was no problem. That's why I feel it was the 12-volt rail. That's our issue. Okay. Yes, I think it was that power supply. I don't see any weirdness at all happening right now. It just looks perfect. Okay, well today I learned that little power supply, which is a modern, expensive thing actually, doesn't really work properly on the 1200. I think the 12-volt rail is insufficient when you're running a hard drive and the floppy drives and stuff like that. And my mean well converted field found one, on the other hand, seems to work perfectly. So this machine appears to be working perfectly, and that is awesome. So I'm gonna spend a moment to clean up my desk. It's a huge mess, and the floor as well. And I'm gonna make some Amiga discs that take advantage of the AGA chipset, maybe some demos, because I wanna see this thing actually flex its muscles, even in stock form, which it is right now, because I have the Accelerator. We'll try that in a different video, but let's see what this thing can do, like as if I had just brought this home from the store in 1992, and I wanna see it, what it can do with the better graphics over my old Amiga 500 that I've upgraded from. So I've been playing with the Amiga 1200 and it's been really fun, I gotta say. It's just bringing back a lot of memories from when I got my first Amiga 2000 that is, but of course this one is quite a bit more capable. Now you'll notice I'm loaded up into Workbench and I actually have the hard drive working. Well, I don't have the original hard drive working. I installed another drive because that one A was not working, but also B was really noisy. The one that's in here now is I think a Seagate 4GB drive. It's a fluid bearing drive, so super quiet, but it's IDE, and as you can see, it works without any issue. I just booted up my copy of Workbench 3.0, which of course matches what this computer would have had when it was brand new, and this detected the hard drive immediately. So obviously this Seagate drive that was in there is not working or something like that because it wasn't being detected. With the hard drive working, I was able to install some programs on the drive, and I have a couple things on here. In fact, there is a picture, a 256 color picture. We can switch over to it. It looks really good. That's an IFF file I converted with GIMP. And on this Amiga, I get to see the AGA graphics, all 256 colors working at the same time. And of course, this is an Amiga, so it's all multitasking, so you can have multiple things up. You can just drag the screens down. So there's the Workbench. And I also have Ed Player, which was the mod player that I used to use a lot back in the day. And let's hit play on this. Beyond music. I also have a few other files on there. And of course, because it's an Amiga, you can totally multitask and run multiple things all at the same time. Even with that picture loaded into memory, plus the mod playing, we still have about 1 megabyte of RAM, which I think should be enough to load something like Deluxe Paint. Let's just give this a try. And I just turned on the volume on the music. So this is Deluxe Paint. We have all these different modes available to us. We'll just load low resolution, also 256 colors. And let's load this up here. There it is. Now, one of the options on this program is the Workbench button here, which will load the Workbench in the background. There it is, while Deluxe Paint is working. Now, we only have 235K of memory, so not a whole ton, but it means that everything is running at the same time on this machine. So of course that means we can load some pictures, like here's Tut 256 color version of it. This is the box art from a bunch of the versions of this program. I had Deluxe Paint on my Apple II GS, and I remember this picture so vividly. Of course, this was the other picture that I remember so vividly, the Venus photo, and this would render perfectly on the Apple II GS. I think there was a 16 color version of it. This has 32 colors, and I think the King Tut photo also had 32 or 16 color version that worked on the GS. But on the Amiga, of course, this is 32 colors, because even the regular Amigas can do 32 colors or even 64 colors in the extra half bright mode. And of course, with an AGA Amiga like this, well, you have all 256 colors available to you, which of course this photo that I took personally of Silver Falls here in Oregon is still visible among all these various programs that are working. So there's the mod playing and Deluxe Paint, and we can switch over to Workbench. There's Workbench still running as well. I remember this so vividly and being so blown away by all of these capability on my Amiga 2000 compared to when I was using a Mac SE, where multitasking on that computer struggled so hard. And well, yeah, it's quite a bit better on here. Now, right now we're down to 354K or so of free memory. When I get the Accelerator installed, and if it works, that means that we'll have a bunch of fast memory, and the computer will run so much more quickly, because right now the entire Workbench and the whole OS is running inside of chip memory, which of course is being used for all the graphics and sound, and that means there's contention with the chip memory and the code that's running the OS and the programs and stuff in that same RAM. When you have fast memory, it has a higher priority, and the OS loads all the programs into that fast memory first, including the OS itself, and that way chip memory is reserved strictly for graphics and sound, and you have much faster animation. Like, notice when I pull this down, it's kind of chunky and slow. With fast memory, I think that will be super duper smooth, although since I haven't used an Accelerator on an Amiga 1200, I don't know for sure. But I remember on my Amiga 2000, even running fast memory made all the difference, and the whole computer felt so much more snappy when you weren't sharing chip memory with programs, and therefore there was no contention issues. But yeah, I just love all the multitasking abilities here, and the mod plays and never slows down, and that's just some of the awesome stuff about the Amiga. Now, I copied sysinfo onto this machine as well, and everything looks as it should in here. And if I do speed, I think the speed of this machine should be exactly what we expect. And you might not be able to see this on camera, but we're running at 1.04 times an Amiga 1200, which I'm sure is just a rounding error. And when we go to drives, we have the hard drive on here, and it just shows up as a SCSI device. And I can do speed. Let's see how fast the hard drive shows up. I think it gets about 1.3 megabytes per second. I tried this earlier. Oh, 1.5 megabytes per second. So this Amiga 1200 is working just as it should. Now, I do have an AGA game here, and it's Chaos Engine. And by the way, I like how the case design of the 1200, you can put floppy disks and stuff right along the top edge. Kind of fun. So we'll reboot the system. And while that's rebooting, check this out. This is the original case. Look how bent the case is. The bottom part of the case has a serious bow on it. That obviously came from when this thing was, well, broken on the top here. Obviously something very heavy was placed on it. I did take off the label off this case because there's no point to keep this broken case anymore. I'll just give that to someone local in the community. And there's the Commodore badge transferred over. It looks awesome. Looks so much better than that one that came with this case. All right, here is Chaos Engine running, which was ported to a bunch of different systems. Pretty sure there was a version of this for the non-AGA Amigas, and I think I had that. Let's start this thing up here. I have to imagine the biggest difference between the AGA version and the normal version was, of course, 256 color support, but also the fact that all AGA machines had at least 2 megabytes of memory, so that was the lowest common denominator, and more of the game could probably load into memory, so you had less disk swapping. One thing I like about the hard drive I put in this thing, you can just barely hear it. You can hear it while it's seeking, but while it's just spinning as it is here, it makes just a very, very quiet whoosh sound, almost like a tiny little fan, a very quiet fan. I do have a joystick plugged in right now, so I can control this thing. So select player 1. This is a 2-player game where 2 players play on screen at the same time, but the CPU is going to be playing as the second player. I think this game came out in 1992 or 93, so it was pretty soon after this machine came out. One of the problems, of course, with AGA Amigas like this is there just wasn't much software. Now, it is backwards compatible with older software, so you don't have any problems running your old stuff. But if you really want to take advantage of the better graphics and stuff, yeah, there just wasn't a whole bunch to... Oh boy, okay, I'm not good at talking and playing. Oops. Oh, the animation is pretty cool. Whoa! Okay, yeah, that didn't last very long at all. I know they ported this game to a bunch of consoles, Super Nintendo, for instance. Oops. And I wonder... Node activated. I gotta wonder... Boy, I'm really struggling to talk at the same time. I have to wonder if maybe having extra buttons was helpful, because this thing, you have to point and shoot, and there's only one button available, really. Well, Amigas actually have support for 2 buttons. Oh, we got some slowdown there. Interesting. Amigas have support for 2 buttons. Obviously, the mouse has 2 buttons, but most controllers are wired up to be like Atari controllers, and they only have 1 button wired up. And most games don't take advantage of the second button. So on this controller, the second button actually is the same as pushing up. Because if I'm playing a platform game and I want to jump, instead of having to push up constantly, I can push a second button. But for this, if I push the second button, it just moves the character up. And I don't know if Chaos Engine actually supports 2-button controllers, but maybe it does. I'm terrible at this game. I remember playing it back in the day. I don't know if it was Chaos Engine or one of the other Bitmap Brother games, but I remember really liking it. So that is going to be it for this video, at least for the meantime. I'm definitely going to have to revisit this machine to check out the Accelerator and see what kind of performance improvements that gives. I saw that it only cost €24 to fully unlock that thing, but it'll be really interesting just to look up the part number, or I think there's a warranty number on there that will tell me what kind of features are available already on there. It's possible it's already fully unlocked, but overclocking this thing to 28 megahertz plus all that extra fast memory will make this computer definitely fly. And now that the hard drive is working on here, that means that I can copy games onto this thing with WHD load. And I have somewhere around a compact flash card, I think it's a 4 gig card that has a bunch of AGA games on there. And the WHD load allows Amiga games that are normally disk-based, like Chaos Engine here that we were just playing, to work off the hard drive. Generally, Amiga games seem to always be booters. In other words, they're not designed to run off the hard drive, but the community has come together over the years and converted these games to be hard drive compatible, which makes it so much easier if you have a big collection and you have a large hard drive like that's in here. You can just copy everything onto the hard drive and not have to worry about having bad floppy disks or bad disk drives. Now, when it comes to the leaking caps, I have to say I got off easy. The damage from these can be so much worse than what was actually happening on this machine. And I actually had a little bit of a worry that the reason why this hard drive wasn't working was because there was some damage to the IDE circuitry in the area of the power supply connector, which is where the caps were leaking the most. I was really relieved when I put in this new Seagate hard drive and it just came up and worked perfectly. So it really is just this drive that was actually the problem the whole time. And finally, I really have to give a huge thanks to James for giving me the Amiga 1200, but of course, all the other accessories for this, like the new case, the extra keyboard, and that accelerator. I'll be really looking forward to a future video where I play with that accelerator and see how much faster that makes this machine. Because as I mentioned, not having any fast RAM really makes the Amiga kind of lag. And it's really a shame that Commodore didn't bundle a fast RAM card with all of these computers. How much would that have cost to just add a 4MB fast RAM card with the computer that would have improved the performance dramatically over the way it is right now with all the RAM contention and CPU contention with that chip memory? So that's it for now. I hope you enjoyed this video. If you did, I appreciate a thumbs up. Hit subscribe if you haven't already. Huge thanks to my supporters. And comment down below if you have any thoughts about this Amiga and things that I've done here. And I guess that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.